Dear friends, we are going to discuss about the Aldol condensation reaction. Because the Aldol condensation they are asking many times in the GPAT exams and as well as for the B Pharmacy students also it's very important along with the other competitive exams. Then it's look very simple condensation reaction, but the thing is that when we will be discuss in detail, you will be come to know what the questions they are arising going to be arise from this particular aldol condensation reaction. Now this is the simple definition for that. What is the definition means 2 moles of carbonyl compounds. 2 moles of carbonyl compounds means either aldehyde or ketone. Aldehyde or ketone. Then what they will be do, which should be having the alpha hydrogen. That's very important in this case. At least they should be have the one alpha hydrogen. You might be take the aldehyde or ketone, 2 moles of any one aldehyde or ketone. In that, at least it should be have the one alpha hydrogen. Then they will be undergoes the reaction with the help of catalyst. That's called as the acid or base. Here you might be confused why we are using acid and base, both are opposite. The reason will be different. For the base sensitive substances we are using the acid, but generally very rarely we are using the acid. But most of the time we are using the base only. Okay, no need to be confused with that. Then here is what, in the presence of catalyst, either it may be the acid or base, it will be undergoes the reaction to produce the beta hydroxy carbonyl compounds. Beta hydroxy carbonyl compounds they are calling as the aldol. This is the aldol reaction. Aldol reaction only up to here. Then next, which on further dehydrated after losing the water molecule, then only it will be produced as the aldol condensation product. This is the aldol reaction product up to the aldol. Then after this it producing the aldol condensation product. That is the alpha comma beta unsaturated carbonyl compound. Either it may be alpha comma beta unsaturated aldehyde, either it may be alpha comma beta unsaturated ketone. For example, we will be go through the reaction of this. This I took the aldehydes. The name of this one you might be know, it is called as the ethanol. Al, remember that, not Ol, or it is also called as the acetaldehyde. I am using the 2 moles of this one more mole. What I told according to the definition, this also same, I am not writing the name again, which should be have at least one alpha hydrogen. This is the carbonyl carbon where the functional group is there. This carbon we are calling as the alpha carbon. This is also alpha carbon. See, on the alpha position, it should be have at least one hydrogen. But here how many hydrogens are there? 3 hydrogens are there. Here also 3 hydrogens are there. It fulfilled or not according to aldol condensation reaction. What he told? They should be have the carbonyl compound at least one alpha hydrogen. This one also have, this one also have. Now see what happened next. In the presence of acid or base, I am using here NaOH. Or you can use acid also. What I told, for the base sensitive substances we are using the acids. Acids, the reaction will be not remain same, but the products are same. Aldol product produces, alpha beta unsaturated products will be produces, but the mechanism little vary, but it will be the same products it is going to be produced. We are not using much that acid, but remember that in the presence of acid or base, you can use any acid also, or then it is going to be produced the alpha comma beta. This is the alpha, this is the beta. Alpha comma beta unsaturated aldehyde. This is the main reaction. What it is going to be produced, I am not shown here how the aldol it is going to be produced. I am showing directly here it is going to be produced this one. Or you can write, I will write even aldol also. This is called as the aldol, or you might be called as the beta hydroxy aldehyde, because this is the alpha, this is the beta. This product only we are calling as the aldol. What I told, after further dehydration reaction, because it is after heating, little when you will be heat, no, little temperature, it won't be it is not stable. Easily it will be loses the water molecule here, this one. Then you might be know, when loses water molecule, one pair of electron helpful for the formation of double bond here. What it is going to be lose then? It loses the water minus H2O. Dehydrated it is called. Then what it will be produces due to the dehydration? It produces the alpha comma beta CH3 CH double bond CHO. This is called as the alpha comma beta unsaturated aldehyde. If I will be take here ketone, it produces the alpha comma beta unsaturated ketones. I am using here only the aldehydes, that's why it is producing the alpha comma beta unsaturated aldehydes. How it will be, already I shown, this is the alpha after functional group alpha carbon, this is the beta carbon. This is what exactly the aldol condensation. I hope you might be understood. 2 moles of aldehydes or ketones which are having the alpha hydrogen, they will be undergoes the aldol condensation reaction in the presence of acid or base. It produces the aldol, then the aldol is called as the beta hydroxyaldehyde. Then after that it will be dehydrated. After losing the water, it producing the aldol condensation product, that is the alpha comma beta unsaturated aldehyde. Up to here, up to this reaction, we are calling as the aldol reaction. Then after this, we are calling as the aldol condensation reaction. Remember that aldol condensation reaction. This one we are calling as the aldol condensation. This is only the aldol reaction. This is the condensation. Why? After losing the water molecule. When it will be lose the water molecule, dehydrated, it is called as the condensation. Remember this. Alpha, beta, whatever it might be, the aldol reaction product is different. That is the beta hydroxyaldehyde or aldol. Condensation reaction product is different. Alpha comma beta unsaturated aldehyde. I hope you might be understood this. Now we will go for the mechanism. In the first step, it is going to be form the, remember that, first step it is going to be form the enolate ion. We are taking the aldehyde which contain the alpha hydrogen. To this I can write little bit different, CH2H, CHO. I can write like this, CH3 only. Okay, for understanding purpose I am writing. It is going to be react with the catalyst, that is base, NaOH. That is Na plus OH minus. I am taking this nucleophile OH minus, then it will be react with this hydrogen. Then what it is going to be loses? It lose the water molecule H2O. It leaves its pair of electron here only. Then what it is going to be produces? CH2 minus, I am writing here CH2 minus HO. CH2 minus CHO. You might be called that this is the carbon ion. No sir, because negative charge present on the carbon. Okay, it is called as the carbon ion. Absolutely, it is called as the carbon ion. But this product, it is not like that. It is not going to be act as the carbon ion. How it will be means, this negative charge, it is going to be share in between this carbon and as well as in between carbon as well as oxygen. Then what happened? Not only this one, it might be produced this one also. H2 double bond CO minus H. This is what? Anion. Because negative charge present on the oxygen is the sharing of the negative charge, it is going to be happen in between the carbon and oxygen. This carbon and oxygen, the sharing will be takes place. That is the reason here it is called as the enolate ion. Remember this. This is very important in this reaction. Actually what we are calling as the carbon ion to this one when the negative charge present on the carbon. But here we are calling carbon ion. In the competitive exams they will be asked, in the aldol condensation, what type of intermediate produce? He will give the option. One option is the carbon ion, another option is the enolate ion, then the third option is the another oxide ion or something like that. At that time we have to be choose enolate ion because the negative charge, it is going to be share between the carbon and oxygen. Okay, that's why it is called as the enolate. I hope you might be understood. In the first step, what it is going to be produces? Enolate. Okay, don't call carbon ion. Okay, don't call carbon ion. No carbon ion, because why? Already I told this one. Now in the second step, we are calling enolate but not carbon ion. Reason already I told. Okay, enolate. In the second step, there is the nucleophilic attack to produce aldol, not the aldol condensation product. Just see here, one more aldehyde we can take. What is that? CH3, CHO. Two aldehydes we use, no? Then, now this aldehyde intermediate, that is the enolate we are taking. I am not calling the carbon ion, remember enolate. I am saying that, just keep in your mind. This is act as the nucleophile, then it is going to be attack on this carbonyl carbon, because it is the positive center comparatively carbonyl carbon is positive center. Then what happens when it will be attacked here, this bond it will be moving here. Now see what it is going to be produces, CH3, then what is there, C. I am writing here O minus. Why? This is going to be attack here. This hydrogen I will write here, okay, here. This hydrogen I am writing here because this will becomes here, okay. Then next what is there, CH2, then CHO. This is the anion actually, but it will be remain like that only? No. Then what happen? It takes the H plus ion. Remember this, from where this H plus ion is coming? From this water, H plus ion. Then easily it gives its pair of electron to this hydrogen. Then what it is going to be formed? Aldol, CH3, CH, here O, this hydrogen, H. Then remaining thing is the same, CH2, CHO. To this also I can write like this, CH, here H. This is called as the aldol, or what I told another name, beta hydroxy, because on the beta carbon, this is the alpha carbon, this is the beta carbon. That's why what it is called, beta hydroxy aldehyde or aldol. This up to here we are calling as the aldol reaction, not the condensation reaction, only the aldol reaction. Up to here what we are calling aldol reaction. In the third step, as I told initially, it will be undergoes the dehydration. The same aldol product, I will write that aldol product, CH3, CHOH, CH. I am using the different colors here for understanding purpose. What? CHO. This is the aldol. Aldol undergoing what? Dehydration. Remember that. What this process is called? Dehydration. Dehydration means you might be know it is going to be lose this water molecule. Then whatever the hydrogen having this pair of electron leaving here only for the formation of double bond. Then what it is going to be produced now? CH3. Then what is that? CH. Next the double bond, because this hydrogen given pair of electron. Then another CH. Then what? CHO. This is called as the alpha comma beta unsaturated, alpha comma beta unsaturated aldehyde. The name of this one, it is also called as the crotonaldehyde. This is very important in the applications. From the acetaldehyde we are producing the crotonaldehyde in the industrial process for the synthesis of this crotonaldehyde. This is very useful, don't be forget, okay. Then what produces? Alpha comma beta unsaturated aldehyde after losing what here? Water. Now this is called as the aldol condensation reaction product. Up to here aldol reaction only. This is the aldol condensation reaction. This process is called as the condensation. Leaving the water is called as the condensation. Okay, don't be confused here. Then this whatever the reaction is there, that reaction mechanism is there, very simple. Initially it produces the enolate. It is not calling as the carbon ion. Why? Already I told, because sharing of the negative charge will be takes place between carbon and oxygen. That's why it produces the anion also, it produces the carbon ion also. In between that two it is called as the enolate ion, okay. Then next step, nucleophilic attack on that enolate produces aldol, okay. Then see here, nucleophile, it means it is whatever the enolate is there, it is act as the nucleophile. This is attacking on the one more of aldehyde to produce the this anion. Then after protonation of this one, from where this hydrogen comes, from the water it is going to come, then it is added this hydrogen protonated to produce the beta hydroxyaldehyde or aldol. Then this aldol product, it undergoes the dehydration to produce the final product, that is alpha comma beta unsaturated aldehyde, or this one also called as the crotonaldehyde, which we are using is the fragrance and flavors. That's why this is very important. The bulk in the industry, they are producing this one. I hope you might be understood the reaction mechanism. The next will go for the applications, which is very important for us. The first application is that it is helpful for the synthesis of, remember this, synthesis of new carbon and carbon bond. How it will be, already we studied in the reaction. In the reaction what? 2 moles of aldehydes, okay, where the final product it produces CH3, CH, double bond, CH, then CHO. It produces or not? Then this is what? It produces new carbon-carbon bond or not? New CC bond. This is the new carbon-carbon bond. It is helpful for the various synthesis. In various synthesis. For what purpose means? For producing the new carbon-carbon bond. Don't forget this. This is one of the application. The second application, as usual we know, this is helpful for the alpha, comma, beta unsaturated what? Aldehydes or ketones. Helpful for the synthesis of aldehydes and ketones which are unsaturated form. For that purpose also. Third one, as I told, this is the what it is called crotonaldehyde. It is helpful for the synthesis of crotonaldehyde. Helpful for the synthesis of crotonaldehyde. Okay, this crotonaldehyde where we are using? We are using in the perfumes. Not only that, we are using in the flavors. Not only that, it is helpful for the synthesis of, as the intermediate, synthesis of sorbic acid. Helpful for the synthesis of sorbic acid. Which one? This crotonaldehyde. Because this is we are using in the perfumes and flavors. Not only that, it is helpful for the, it is used as the intermediate in the synthesis of sorbic acid. This sorbic acid we are using as the food preservative. Remember that. Food preservative. See how many applications it have. You might be think up to here only these applications. No. Still many more applications it is having. In the industry, it is helpful for the synthesis of pentaerythritol. Remember this pentaerythritol. This pentaerythritol we are using in the paints, we are using in the varnishes and other things. Now next application, fifth one, it is also helpful for the synthesis of cinnamaldehyde. This cinnamaldehyde we are using in case of perfumes, fragrance, flavors, this cinnamaldehyde. Next application, it is helpful for the synthesis of various drugs like antibiotics, like anti-cancer agents, like steroids, like anti-inflammatory agents, many more. This is in the synthesis of the various products, pharmaceutical products. These are also helpful in the synthesis of natural products. Natural products. What are those natural products? Like alkaloids, like terpenoids. The important thing is that it is also helpful in the Robinson annulation. Robinson annulation where we are using the aldol plus Michael addition reaction, Michael addition product. It is helpful in the synthesis of 6-membered ring. Especially it is helpful in the synthesis of steroids. It is also helpful in the carbohydrate metabolisms like glycolysis, the other process. In all those cases it is useful. These are the applications of the aldol condensation reaction. These are the catalysts. These are very important in the competitive exams. They give the number of options. They will give like NaH, sodium hydroxide, KOH, K2CO3. They will ask A and B or B and C or all. At that time all these are their catalyst, means you can use the all option. You cannot say we discuss only the sodium hydroxide HCl, because sodium hydroxide HCl only the catalyst and these are not the catalyst. It is not like that. That's why I am writing here. In the competitive exams, we should be remember all these catalysts we are using. What they are? LDA, lithium diisopropylamine, N-butyl lithium, sodium hydride, then the lithium hexamethyl disilazide, then sodium hydroxide, potassium hydroxide, barium hydroxide, sodium methoxide, potassium carbonate, then the acids also we are using. When we are using acids, I told, when the products, whatever it might be, the aldehydes or ketones, carbonyl compounds, when they are base sensitive, okay, when base sensitive. When they are base sensitive, we are using this hydrochloric acid or sulfuric acid, phosphoric acid, paratoluene sulfonic acid, in that case only. Sometimes we are using Lewis acid also, zinc chloride, aluminum chloride, and TiCl4, trifluoroborane, then stannated chloride, magnesium bromide. Then organocatalyst also, proline, pyrrolidine, secondary amine, diamine, imidazole. Enzymes also we are using like aldolase. Means we have to remember all these things. How they will be asked in the competitive exam means, A, they will be keep the NaOH. Catalyst what we are using. B, they will be keep the HCl. Then C, they will be keep the both A and B. Then D, they will be keep the potassium carbonate, K2CO3. Okay. Then they will be asked, they will be, these are the options. Then what you will be do, sodium hydroxide you know, HCl you know. That way you choose the option C. But this option C is wrong. What is correct actually? Then another option also there, all. Then we have to be choose all, because this potassium carbonate also we are using. That is the reason you should be know all the catalyst. I hope you might be understand. Thank you very much for watching this video.